For every vacuum pump and compressor that K&F manufactures, a flow curve is generated to illustrate the expected performance capabilities across the rated pressure range. The performance is mapped on a chart like the one shown here, where the x-axis is pressure and the y-axis is flow rate. The center line represents atmospheric pressure, so that the left half of the curve displays vacuum, measured in millibar absolute or inches mercury, and the right half represents pressure, measured in psig or bar g. The pump's performance, known as flow rate, is measured in liters per minute. Regardless of the units, your interpretation of the flow curve will be the same. The point in the middle where the two curves meet is the pump's free flow or maximum flow, meaning there is no restriction or pressure on either side of the pump. The endpoints of the curves represent the maximum vacuum or maximum pressure capabilities of the pump, where the flow rate is dropped to 0 liters per minute. In this example, the inlet of the pump is connected to a vacuum gauge, and the outlet of the pump to a flow meter. Without any restriction, the free flow rate measures approximately 6 liters per minute. As the valve is closed on the inlet side of the pump, the measured flow rate drops as a deeper vacuum is achieved. Notice when the vacuum gauge reads 550 millibar absolute, the flow meter shows approximately 2.1 liters per minute, which matches the flow curve. Maximum vacuum capabilities of the pump are measured by completely closing the valve on the inlet side of the pump. When the flow meter displays a flow rate of 0 liters per minute, the vacuum gauge will display the maximum vacuum generating capability of this pump. In this example, the outlet of the pump is connected to a pressure gauge and the inlet of the pump to a flow meter. As before, without any restriction, we measure a free flow or maximum flow rate of approximately 6 liters per minute. Closing the valve on the outlet or downstream side of the pump causes an increase in pressure. This pressure increase causes a decrease in the flow rate. Let's stop here in the middle of the curve and measure the flow rate at a pressure of 22.3 psig. Notice a flow rate of approximately 2.3 liters per minute, which matches the flow curve. Maximum pressure ratings of the pump are measured by completely closing or deadheading the valve on the outlet side of the pump. When the flow meter displays a flow rate of 0 liters per minute, the pressure gauge will display the maximum pressure, which in this case is 44.5 psig. It is important to note that pumps will often generate more pressure than the rated pressure capability on the datasheet. Running the pumps above the rated pressure may have an impact on service life and could cause premature wear or failure. What happens to the flow rate when there is restriction on both sides of the pump? This example will demonstrate how to use the flow curve to estimate the flow rate performance of a pump when both vacuum and pressure conditions exist. Here, a long length of tubing with a small inside diameter is connected to the inlet side of the pump, and a small restrictive orifice is connected to the outlet side of the pump. By T'ing in the vacuum gauge, the display shows 887 millibar absolute of restriction created by the tubing on the inlet. On the outlet side, approximately 10 psig is measured on the pressure gauge teed in between the pump and the orifice. Through a simple manipulation of the flow curve and chart using the two data points, the curve indicates an estimated flow rate of just under 3 liters per minute. A flow meter connected to the system confirms the estimate calculated through the flow curve manipulation. 2.94 or approximately 3 liters per minute is shown on the flow meter. To summarize, when both vacuum and pressure conditions are known, the flow curve of the pump can be used to estimate the flow rate. Standard K&F pumps are capable of operating at any point under the given performance curve, but where we specialize is in our ability to also operate above the curve. Through our modular design approach, K&F works with customers to provide custom products that exceed our standard performance boundaries to meet the demands of each unique application.